Hi there, this is 9.6, identifying conic sections. So, we've been learning about conics, but what is a conic? Were we told what a conic was? No, we just said, well, we have a parabola, a circle, and an ellipse and a hyperbola. Well, how are they formed? Okay, they're formed when you have a double cone, like this top of this page right here, set next to each other, and you take a plane and cut it. If you cut it this way, you get a parabola. If you do it more at a horizontal, if it's a horizontal, it's going to be a circle. If it's a kind of a slant a little bit horizontally, then you're going to have an ellipse. So this way it'll form either a circle or an ellipse. And when you vertically slice it with a plane, you're going to get a hyperbola. Okay, so what are our objectives for this section? We have two objectives. We're going to write equation of conic sections in standard form, and we're going to identify the conics from their equations. Okay, so basically we're putting this all together. If we go back to our section, so an equation for a conic can be written in the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, and c are not all zeros, and this is called the general form that we can convert to standard form by completing the square. Now it's important to know that a, b, c, d, e, and f are constants, or real numbers. Okay, so here's a summary. Again, this is our key concept box, and it's going to be really important to know this, that here's the equation for a circle. Here is a parabola. This row is for the ellipse and hyperbola. So they just put it all together where we did them one section at a time. Now, it's important to note on the ellipses that here A is always going to be the greatest between A and B. A is always going to be bigger than B. On a hyperbola, it's sometimes, not always, A is greater than B. So it's important to make that difference. But you still have to have the right form, because remember we have a minus here and order matters. So keep that in mind, that A is always bigger in the ellipse, so it's always going to go where, if it's under the X, it's a horizontal. If A is under the Y, then it's a vertical. Here, A is not necessarily the bigger of the two. So we can't look at it that way. So let's start going directly to our example. It says, write an equation of a conic section. So given this equation in standard, write this equation in standard form. State whether the graph of the equation is a parabola, a circle, or hyperbola. And then graph the equation. So we first have to start with what is our equation? So we have, and we're going to regroup, so 16x squared minus 28x, okay, plus, I'm going to go ahead and tie that negative 25y squared equals 144. Okay, so just like before, we have to complete the square in order to put it in standard form. So I have to factor out a 16. Remember, this has to be 1. X squared minus 8x plus, or this becomes minus, right? Because I'm going to factor out a negative 25. So minus 25y squared equals 144. Now I'm going to complete the square. So 8 divided by 2 is 4. 4 squared is 16. So really I've added what? Plus 16 times 16, because I factor out a 16 times whatever this value is what I add to the right side. I didn't do anything here. So then I have 16 is x squared minus, x minus 4 squared minus 25 times y squared equals 400. Now, I need to get rid of this 16, so I have to divide every term of the equation by 16. I also need to get rid of that 25, so I have to divide everything by 25. Remember, what I do to one term, I must do to all terms if I multiply or divide. This cancels, so I get x minus 4 squared over 25 minus, this cancels, y squared over 16 equals 1. There's your equation. It's equal to 1. I have a minus, so this is a hyperbola. How do I graph it? Well, what's my HK? It's 4, 0. So 1, 2, 3, 4. That's my center, okay? Because x is the dividend, or I mean the minuend, and not the subtrahend. It's going to be horizontal. So, and it's A is going to be 5, and B is going to be 4. So I'm going to go 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units here, and that's going to be my vertex. Remember, HK is your center of the hyperbola. That's half the distance between vertex. I know it doesn't look like it. And there's your parabola. Okay. That's it. You just got to be able to put it in standard form by completing the square. Now, just like we had some using the discriminant for parabolas to identify how many zeros and roots, we're going to use the discriminant again of the general form to identify what kind of conic we have. So it has to be in ax squared plus bxy plus cy squared plus dx plus e in the general form. When it's in this general form, and there's an xy term, so when there is an xy term, which means b is not 0, you can use the discriminant to identify the conics with the b squared minus 4ac. All right, so we still got to make sure it's in the right form. So when we do the discriminant, b squared minus 4ac, and let's start down here. When it's greater than 0, meaning it's positive, it's going to be a hyperbola. When it's equal to 0, it's a parabola. When it's less than 0 or negative, it can either be a circle or an ellipse. How do you know? Well, to be a circle, b has to equal to 0, and a and c have to be equal. So these two coefficients have to be the same. If b is not equal to 0 or a is not equal, if one of these cases is not true, then we have an ellipse. Okay, so when b equals 0, the conic will either be vertical or horizontal. When it's not equal, it's going to be neither. It's going to be a slant, and we're not going to get to those now. We'll get to those much later. Why they threw that in, I don't know. So let's look at example 2. It says, without writing the equation in standard form, state whether the graph of each equation is a parabola, a circle, ellipse, or a hyperbola. So let's go directly to our example 2. So A, first of all, I'm going to rewrite this in the general form. 4x squared minus 3xy plus y squared plus 4x minus 5y minus 8 equals 0. The reason I did this is because now I can say this is A, B, C, D, E, F. And I need b squared minus 4ac, which b squared is negative 3 squared minus 4 times a times c. So I have 9 minus 16 equals negative 7. So it's negative because it's less than 0. I have two cases. It's either going to be a circle or it's going to be an ellipse. So we said to be a circle, b has to equal to 0. Is b equal to 0? Nope. So it's an ellipse. So right off the bat, we can say this is an ellipse. Let's look at number 2b. Again, I'm going to rewrite it in the right form. So 3x squared plus 2xy, I'm going to write in the 8x squared plus bxy plus cy squared, so on, so on, in the general form. You have to memorize that. So it's the x squared, the xy term, the y squared, then the x term, and then the y, and then the constant. Okay, so again, identify A, B, C, D, E, F. And all I care about is A, B, and C, right? So B squared, so 2 squared minus 4 times A times C. So I get 4, negative times negative is a positive, 60, so I get 64. So it's positive, meaning it's greater than 0, so I have a hyperbola. So what I need to do to get this right is I need to look at my chart right here. And it tells me, right, if it's greater than 0, it's a hyperbola. If it's equal to 0, it's a parabola. If it's less than 0, it's negative, it's either a circle or ellipse, and I have to look at my cases. Let's look at C. So again, I'm going to put this in the right order. 4y squared minus 8x plus 6y minus 14 equals 0. Remember, it's ax squared. So a is 0, because I don't have an x squared. Bxy, so b is 0. So this is C, D, E, and F. So 0 squared minus 4 times 0 times 4 is 0 minus 0, or 0 because it's equal to 0. I have a parabola. All right. So you have to know this information. You got to know what the general form is of a conic, and you have to know how to put it in standard form. And you have to be able to identify A, B, and C, and find the discriminant and use the discriminant as well to help you determine what type of equation is. All right, do the practice problems, and we'll see you in class.